Hey everybody, so this is your solution guide for part 2 to your midterm. For part 1, a lot of them came directly from homework assignments and things like that, so you should be able to look up those resources or use the Ask a Question forum to get some help on those problems. So I'm going to focus all of my energy on the part 2 here. So we'll start with question 1, which was a composition of functions question. So here we've got 3 different functions, f, g, and h. And we're being asked to find and no need to simplify the following expressions. So we'll start with f of 2a. So for f of 2a, we're talking about taking the input of 2a and inputting it into the function f. So wherever we see the input for f of t, which is t, we'll be putting in this 2a. So now here, this is simple enough to simplify, and a lot of us did. But remember that the 2a, the whole thing gets squared, so that becomes 4a squared. So you've got 3 times 4a squared plus 2a, which is 12a squared plus 2a. Okay. If you just got it here and left it, that's totally fine too. So for b, it's saying now, instead of giving us the expression to input, it's saying, I want you to input f into g. So what is g of f of t? So that means I'm going to take the rule for g, which is radical 6 plus 3 times my input. All right, 6 plus 3x. But in this input, I'm inputting what? I'm inputting f into here. So I'm going to give myself a little room. Say this is 3t squared plus t. All right, now you can take it one step further too and just distribute that through. So that'd be 9t squared plus 3t. And it doesn't get any better than that. So, and again, this would have been fine as well. So again, finding what your input is, putting it into wherever you see the input variable for the rule for the function, for the outer function. And then for C, we're being asked to find what happens when you plug in g of x into h of r. So in this case, and you might have noticed that I've been doing this, writing out the function 3 times the input plus 5 over the input squared, taking out that input variable and replacing it with brackets so that I can now input what? G of x. And what is g of x? It's radical 6 plus 3x. Now, the biggest thing I saw on this problem were some kind of bad algebra issues. So things that kind of come from before this class, exponent rules, canceling. For example, people felt very compelled to cancel 6 plus 3x in this expression, where we should see after careful inspection that that's not the case, right? Because this doesn't have a factor of 6 plus 3x in the top. So just to leave that as is. And I also saw some copying errors, like, x's being dropped and things like that. So just slow down, make sure you're taking your time to copy down the questions precisely. All right, so I hope that helps for number 1. Okay, and for number 2, we were given an applied rational functions question. So some of us, I saw some questions like, I haven't seen many of these before. We did do a couple of these. One was in the lecture video, and there were a couple in your practice assignments on applications of rational functions. So it's worth a while to go back and brush up on that. So here we're creating A of G, which represents the average cost to produce G grams of the drug. So for this, we note that the startup costs are a total of 15 million plus 1250 per gram. So we kind of have this cost function, which most of us got, and then dividing by the number of grams is how we figure out the average cost, right? So dividing by the total. So you have the linear function of cost, but you divide it by the total grams to get the average cost. And then the company determined that when the average cost, A, is equal to 1,500, that they are profitable. So you can set up an equation to figure out what amount of medicine or drug aka what quantity of g makes this the case. And so you can solve this for g by various methods, but one would be to multiply both sides by g over 1. And then set up a pretty easy linear equation, and we should solve that. G equals 60,000 grams or 60 kilograms. Okay, so anything over that amount will bring the average cost below 1,500 per gram, and then it becomes profitable, as they say. And then in this part C, identify horizontal asymptotes and vertical asymptotes. Well, for this, we need to look at the structure of our function. So I'll write it over here. Plus 1250g all over g. So horizontal asymptotes for a rational function, you're looking to see, well, if there is a dominance between the polynomials in the top or bottom. So if one is a higher power than the other, that tells you something. If they're the same degree, meaning the degree of the top and the degree of the bottom are the same, that means now that in the long run, the horizontal asymptote will balance out to be the ratio of those two leading terms. So in other words, 1250 over 1, over that implied 1. So the horizontal asymptote here would be y equals, or a equals, pencil's glitching out here, a equals 1250. And your vertical asymptote would be at g equals 0. It's going to be undefined there, right? So the function cannot cross that line. And so to interpret these in the significance of, or rather to explain the significance in context of the problem, that means in terms of drugs and cost, right? The amount of drugs and the cost. So for g equals 0, you've produced none of the drug. And so, what is the average cost going to be? Well, this is like, why even get started if we haven't produced anything? So the cost will be infinite per item if we haven't made any grams of the drug, okay? So that's one way to kind of explain that. What's more applicable is the horizontal asymptote, which is the long-run behavior. So what does that mean? Well, the long-run behavior being 1250 says that over time, the average cost per item will be $1,250 per gram, which is the cost to produce the drug. So we know that we're going to be approaching that just cost per item, that flat cost per item, and that we can't go below that, right, unless that changes in the long run, which based on our model, it doesn't. So what it means is we're heading toward just that cost per item, that fixed cost per item. If that were 0, it'd be 0, but usually there is some residual cost there. So I hope that makes sense for question 2. Again, you can look back to our unit on rational functions for some similar problems there. Okay, and so for question 3, we've got a Forerunner costs $52,000, and it depreciates over by 24% during its first 5 years. So here, the language is really important. So I saw a lot of people get confused on what this really meant. A total of 24% during its 5 years means it's lost that much value. It doesn't mean that it lost that much every year. So it didn't lose 24% every year, which is a common issue I saw. So what is the car's value after 5 years? So it's lost 24%. So one way you could think about this is then it's kept 76% of its value, and that should be $39,839.20, I believe. Let me double check that. Yeah, so this is the value of, again, going straight from 52,420, losing 24% over the 5 years total, and this is the resulting value after those 5 years. So for B, it's saying, assume this depreciation is exponential. Find a formula for the value of the car when it is t years old. So you're looking for annual change. So here's where you need to find the annual percent rate of change. What we were just given was the percent change after 5 years. So this is finding the formula for a exponential function. So it's going to be something like a times b to the t. And it's we're assuming annual decay, but you could have gone with continuous decay. That'd be fine. But here, we know the initial value is 52,420, so we can actually just start with that. That's when t equals 0 times b to the t. And we also know that at t equals 5, this is what our value of the car is, 39,000. Okay, so we also know that v of 5 is 839.20. So we know that 52,420 times b to the 5th power is 39,839.20. So here's the part where a lot of folks got mixed up, because we're solving for this b. It's not 0.24, it's not 0.76, it's whatever this growth factor is raised to the 5th power, so, or decay factor in this case. So we divide both sides by 52,420. You get b to the 5th equals this number here. And then do what? Raise both sides to the 1/5 power, right? Or take the 5th root of both sides. And what you should get is 0.9466, which makes sense. It means it's losing roughly, 5.5% of its value every year. Okay, but that's not a linear percent rate of change, right? So I saw some people just divide by 5 years. That's not what we're looking for here. So this is our decay factor. And so then that means that the formula could be represented by this or something equivalent. If you used E or just wrote it similarly with R instead of your B factor, that's okay. All right, so that's an exponential decay model. In part C, it says, suppose the depreciation is linear. So that means you're assuming that we have some constant rate of change, some slope, which is the change in the value over the change in time. So it'd be 52,420 minus 39,839. And actually, I would typically write this the other way around, because I go from end minus start. But as long as we keep the points oriented properly, we'll get the correct value. So this will work out to be negative 2516.6. So losing $2,500 per year is what this model would assume. And so we have the starting value, so that for a line, v equals b plus mt. We'll get v equals, we know the starting value is 52,420, and it's losing a flat 2516 per year times t. So that'd be our linear model here. Okay. I saw some folks like multiply the percentage, times 5 years or something to come up with a different slope, but here it's really just using the average rate of change and saying that's constant. And then for part D, saying which would you prefer? Well, you're looking at, v of 3. Maybe we'll call this v, instead of having them same name, we'll call this v exponential and this v linear. So comparing ve of 3 versus the L of 3. And you could have done this in various ways. You could just plug it in and solve. But what you'll see here in this case is at this value, the linear model is higher, which means it's lost less value. So we'd prefer that one for this. I saw some answers that didn't quite make sense on, the preference. It's really, you want your car to depreciate the least. So you're looking for the higher value. You'll notice, though, after another year or two, it becomes the other way around, where the exponential is actually holding a higher value than the linear, losing that flat 2,500 every year versus just losing, 5% each year, because you're only going to be taking 5% of a lower value, which means it will decay less and less and less. So I hope that part makes sense. So last one is question 4. And this is the Domino's Pizza question. So again, I saw a lot of people using linear growth here when we're really talking about percent rate of change. So for part A, you're really setting up a exponential growth between at t equals 0, there were 300 stores, and at t equals 8, there were 5,000 stores. 5,000. And so one way you could set this up is by saying, all right, well, the number of stores, so part A is actually asking for the percent annual increase. So you could assume that this is part of a annual growth function where you start with 300, multiply by some growth factor for 8 years, and this should leave us with 5,000 stores at the end. So remembering that this A times B, that's the initial value. So very similar to the last problem, solving for B tells us that B is equal to what? 50 over 3 to the 1/8 power. And so that tells us that B is actually 1.4214. And so I saw some people grab this and say this is 1.42% increase. No, remember this is 1 plus R. So your rate of increase is really 42.14% annual increase. Okay, so it's a constant percent rate of change. For B, it says assume the percent growth remains constant. I think this is where folks maybe took this to mean linear. It's still percent growth, so it's based on how much there is of the quantity. So that means we're talking exponential growth. So we basically have it just by doing this previous problem. So we could say S equals or Q equals whatever. Oh, here it's asking for D equals PT. That's fine. It was different on the older sheet here. So D equals, started with 300 times 1.4214 all to the T. All right. And for C, determine when, grab an equation that will determine the year when the 2000th store is open. So that would be 2000 equals the right-hand side of my equation. And then we're obviously solving for T. And this should come out to be, depending if you do this graphically or algebraically, either one would be all right. We should get 5.39-ish, which means, and asked what year will this happen? So this is in the year 1986, because it's about in the year 1986, because it happened, after that 5 years in mark. So 5.4 plus 1981 puts you at 1986 and some change. So, and the last part asks, give a reason why, explanation why this trend is unlikely to continue. Well, we know that, the exponential growth model is going to increase explosively without bound. It doesn't tail off, whereas we know in the real world, there's only so much demand for Domino's Pizza. There's only so much real estate, so much, money that can be made. So there's a lot of limiting factors. So it obviously won't tend to infinity. So any explanation kind of pointing to that would be acceptable here. So I hope you found this helpful. And again, you can use the class discussion forum to ask any questions. For some of you, I've left some notes to reach out and set up an appointment with me to work. And I hope you do that very soon. All right, but overall, great job, and I look forward to hearing from you all. Bye-bye.